Then we welcome Alejandro Aragon from Delft University. And let's see, we have yet another long title that I can get lost in. Maybe I can just do the abbreviation. Arcade. Yeah, which is augmented reality, computational analysis and design environment, an interactive playground for real-time immersed topology optimization. Thank you,
Niels.
Yeah, thank you. Please take it away.
Thank you. I'm very excited to be here in Japan. Actually, it's my first time. I practiced karate many years, so it's been like a lifelong dream to visit Japan. So very happy. Anyways, this is going to be a different type of presentation for me. So normally I would give a research presentation on some numerical technique or level set based topology optimization. But over the past couple of years, we have been developing something that we believe it's very nice in the direction of an educational application. So since I am in Japan, I thought, well, maybe I give a twist to the type of presentation that I will give, and so I decided, well, maybe it's a nice way to do this by doing some manga type of presentation, right? So now that we have all these generative design tools available to us. And so, well, of course, this is my work, and it's also in collaboration with Hendrik, who is currently at Technion University doing his PhD. And so I wanted to tell you a story. There is no research involved, and it's just basically a translation of the 99-line code into Swift, and then we put that into the Vision Pro so that we can actually do topology optimization in an immersed setting. And so I'll just tell you a story of how all of these developed. So as Neil pointed out, Arcade stands for Augmented Reality, Computational Analysis and Design Environment, and of course it's an application that we developed for the Vision Pro, which I have here, and I will give you a live demo. But before that, hanging there with me a bit, I'll tell you a little bit about how we came up with this idea. So everything started 2 years ago. So if you can raise your hands if you were in Cork 2 years ago. So some of you were there. Of course, this community is a very nice, friendly community. So we learned about the new dance. So for those of you, this may bring nice memories. We also learned about the new sport. You have to pass it, I said, like, in most sports games. But at the same time, Apple was introducing the Vision Pro headset. It actually happened during the conference, right? And I remember this happened that we were this is a photo of the whole group from Delft. During that same night, we were in a bar, and I told these guys, how about we do topology optimization in this Vision Pro? It would be very cool to do this. And yeah, there were some skeptics in the group. I remember some say, yeah, I don't think that's possible. And okay, well, that idea stuck. Of course, we knew that it was possible. And since you had to give credit where credit is due, thank you, Niels, for all the hard work, Niels and coworkers at DTU, who have developed continuously all these educational apps, which are great. Who has an educational app from Niels in the phone installed? Yeah, so you should be more. I'm pretty sure in Delft we have more people. Anyways, so we knew it was possible. The idea was how, and so I started to look into this. And of course, the first thing you come across is that if you wanted to do this for the Vision Pro, then you have to learn Swift. You have to learn Xcode, and yeah, that's a kind of a bummer because you cannot really reuse the things that you learn over the years. But then you start learning, and I guess if you know how to program in one language, you know how to program in all languages. You just need to learn the syntax well, with some caveats here and there, but that is what it is. And so I got excited. I got very excited at some points where things were working, and of course I got also very frustrated when things were not going my way. And well, since usually the urgent stuff doesn't leave you time for the important stuff, this was put in a drawer and I forgot about it, but I knew that we had, let's say, 2 years, because my goal was to present this work in this conference. I knew that someone else had the idea, probably they would do it, and so I tried to figure out a way to move forward. And so I thought, well, maybe I'll just write a little grant to get some money. And well, I got some money. It was, I'm glad it was more than 250 euros, right? So I could support someone to do to help me a bit with the development. And I remember I asked ChatGPT, but back then this was what I actually used in the proposal, and yeah, this sparked some interest. The faculty decided that it was very nice to grant a small grant to pay for some development time. And I also got a voucher from the department. They said, well, if you really want to do this, yeah, we can buy the device for you. And it's actually a very expensive device, so I'm very happy the department did it. Otherwise, I wouldn't be standing in this presentation. And this is where this gentleman shows up. So Hendrik, he did his master assignment with me in Delft. He did actually really nice work on the topology optimization of nanomechanical resonators, those high Q factor nanomechanical resonators. Again, following some of the work of the people at DTU. And he did nice work, and I was so happy with his work that I said, well, hey, Hendrik, why don't you take this little time and then help me code this application? And then he got excited about it too, and so he started coding, but for a long time we did not have the device. Actually, it was not possible. It is actually not possible today to buy the device in the Netherlands. So we spent a lot of time coding and we had a simulator, but we could not test it, right? So at some point, there were some features that we needed to test in the device, and so we were basically like driving in the dark. We didn't know what was going to happen. And so we finally managed to find a way to buy the device. So I bought it in Germany. We shipped the device to the border, right? Imagine all the hell we had to go through to get this to work. And then Hendrik drove, because his family lives nearby the border, and so he drove back and forth. And then, well, he's happy, of course, once he got the device. I told him, do not open it. I want to open it. He didn't listen. He didn't listen. He ended up opening the device in his place, but well, okay. And so there we are, very excited. We managed to make this work, and well, but before I show you the demo, I just want to have a couple of more minutes to discuss some things. So we did write an educational article. It's in the archive at the moment. We submitted to SMO. Of course, it's very rough at the moment, so there are some edges we have to trim still. And we also put the application in the Apple Store, which you can actually download for free if you happen to have one of these devices. I am truly hoping that Apple is going to release a cheaper version of this because it's still very, very expensive. And finally, I want to just draw your attention that if you happen to be looking for a postdoc position, I do have a 2.5-year postdoc position open in my group to look at computational design for metamaterials and also controlling fracture of metamaterials. So with that, I guess I will show you a little bit of what this thing can do. So okay.
Alejandro, are we supposed to see something?
Yes. Are you seeing now?
Yes.
Yeah. Okay.
Yeah.
So you should be able to see what I see right now.
Okay.
And well, of course, it's an immersed platform. It's actually a computer, so everything is happening here, right? So you have the applications, and well, you basically use your hands to play with this. And someone sent me a message, but of course I'm not going to answer right now. So we developed, this is arcade, so I'm gonna put this in a place where it doesn't bother me, right? So as you can see, there are some tabs. I'm also going to try not to move much, so therefore I'm gonna place it. Sorry, Alicia, going behind you. Actually, no, okay, never mind. Anyways, so you can see that there are four main tabs here. you get into the computational domain tab, and you can see it, so you can actually interact. So you can move this thing around, and if you want to resize, you can just pinch and drag the faces of your computational design. I can do this with all of that, right? And I can move it around. I can rotate it. Okay, well, say I'm happy with this computational design. And so, what do we do next? No.
Supports.
We go to bond. Come on, guys, you should all know this. So this is where we define boundary conditions, and of course there are two types of boundary conditions: Newman, Dirichlet, or forces, tractions, and displacement, prescribed displacements. And so everywhere that you see a red boundary condition, that is an applied traction. If you see a blue, that is a prescribed zero displacement, and I can basically tap any surface, any edge, or any vertex. I can basically play with these gestures, like pinch and drag gestures, to increase the magnitude of the traction, so I can give a huge force if I want, right? But for the purpose of this demonstration, let's just go with the bridge, because everybody knows what the topology of a bridge is, just in case, right? And so what do we do next? Well, we go to the optimization, and here we have some parameters. Of course, right now it's limited what we have done. We can still add a lot of more stuff, but since it is an educational application, after all, I'm not sure I want to put a penalization parameter there, because, well, most people are not going to know that. But we will see. There is a lot of things, and I'm expecting to get some feedback from whoever is going to install the app. For the time being, we can set some maximum number of iterations. We have a volume fraction. We can determine the mesh size, and let's say I want to reduce it a bit. And then we can choose for an iterative solver or a direct solver. And then when we're happy with everything, we just click Start Optimization, and we should see our design to life. And what you hear is a Rubik's Cube sound. So I thought it would be cool, you know. But anyways, when you're done with your design, you can actually go and you can inspect it. Right? You can see around. And if not, if you're happy, otherwise you can change some things, right? And if you want to get closer, you can see, oh, here's something I don't like. Okay, so then I'm gonna change the optimization settings, and I'm gonna run it again. So let's go to some cantilever beam type of optimization. All right. So I'm going to put it next to Alicia right there. I'm going to take a photo. There you go. Okay. All right. So, of course, we do have plenty of time. So I am hoping that some of you will test the app. I know Niels is dying to do so. So he's going to try to find the bugs, which of course there are here and there. But well, thank you so much for the attention.
Thank you, Alejandro. We have plenty of time for questions. And maybe I can just go first. So this, as you say, is an expensive piece of equipment.
Right.
Have you already considered porting it to something that's more affordable, like some of the meta lenses or something like that?
Yeah, so someone asked not long ago about this, and of course that's a possibility, but of course everything has to be rewritten, right? Because this is using Swift.
ChatGPT, rewriting code,
Yeah.
done. I mean, that should be an afternoon's work for Hendrik, I guess. Okay, but please, questions for Alejandro.
Very nice example. Could you say, what about the following the object? Because it seems that your beam was put in one point of the image. You are moving circular, and it seems that your beam was located in one point. So that means all objects are put in a fixed point, or they can move.
Basically, the way this works, this virtual environment defines some zero coordinate system.
Yeah, but that's my question, because it seems that your objects are put in steady points. They can, if you are, because your head acts like camera. So when you are moving your head, so you change the position of the camera, so our perspective should be different. And it seems that especially this perpendicular beam was put in exactly one point.
Yeah, and it keeps that point. So it creates a space that is aware of your space surrounding you. So you can place an object, and whenever you leave that object placed there, it's going to be the coordinate system with respect to where you are, right? And so you can move around the object. That's why things don't actually move unless I want to move them.
And what about the blurring? Because it seems that this room is perfect for you because it's maybe 10 meters length.
Blurry, you said?
This room is perfect for your example.
Yeah.
Because it's not so long, so we can see very clear in your screen. But what about, for instance, room A, that you have 50 meters long?
Yeah. So, of course, the long vision would be that I am standing in a river and I should be able to do something to design a bridge, right? Yeah, but for now, it's just a proof of concept. We cannot go very big in dimensions at the moment. This is a computer, but it's still a limited capacity computer. So even if we go to very fine meshes, we start having this latency. So for now, it's just a proof of principle, but of course, eventually things are going to get better, finer, bigger.
What is the price of this device?
That's okay, Alicia, you're up next.
I think it costs like 4,000 euros, 4,500 euros.
Yeah.
But I understand that in September, I think Apple is going to release a light version of this. So hopefully it will be also reduced in price, because I understand that they didn't do very well with the sales because of the price.
Yes, Alicia first, and then you. Alicia?
What was I going to ask? So two questions. One is that if you have like an internal hall and things, are you able to actually go in and like look at the whole thing? The second question was, what was the memory that was available to use?
For the first question, we did not generate any topology that would create a hole internally. So I'm pretty sure I can do this because it's spatial, it's aware of the space, so I should be able to go in and check. But we never really tried that. And in terms of memory, well, this is using, it has an M3 chip, I believe. So I don't recall exactly the amount of memory, but it is like coding in your Mac. So it's a personal computer.
Right.
So it's pretty capable.
Yeah, it's very capable.
Yeah.
What is your next plan then?
My next, with this?
What see in the next conference?
Well, I'll present this in the US in a few weeks, right? In US NCCM. My next plans, I talked to Niels, and I know how hard, according to Niels, is to continue supporting this, and it takes a lot of effort. So I hope I can manage to keep adding some things whenever I get some time. But time is a very scarce resource for all of us. So we'll see. I don't know at the moment.
We have time for one more question, and then according to the program, we should move on. So, final thing, or people just want to go and test it? I think that's the case. Let's thank Alejandro once again. Thank you. And by the way, that concludes this session. So I suggest we thank all the presenters. Thank you very much for the time.
Ready?
Yeah, I want to try.
Can I at least have a look?
Me first, Alicia,
Oh, you
not
can
ladies
go, but
first.
I just want to have a look at it. Okay, I do want to have a go, but
Yeah, but I also use glasses, so it's okay.
I use your phone.
Yeah, I like it. Thank you. You have to. But I have to wait. I have to give you guess one second. Okay.